Hey there folks, welcome back. So in this section we'll take a more detailed look at the working of a switch or point turnout. So in this example I have used a right arm turnout, a right arm, and which is connected with a straight section of a track and another straight section of a track and a third straight section of a track. So this is a track which is merging. These are the two branches which are merging onto a single section of a track. So either you have traffic coming in from here, you can split it to go on the right hand side, or you can split it and let it pass straight, or if you have traffic coming in from the top or bottom branch, and you can channel them onto the single section of the track. So this is quite an important piece. And as I said before, the working of these switch points in Fenfa kits, there's a physical mechanism. Down the line I do plan to add some electronics and gears and motors into this to make it automated, but for the time being I'm just gonna use all of them manually, as I do in also all of my layouts. So you can see these are the moving arms of the point, the moving sections of the rail track which help with the alignment and choosing of the direction. And in this setting it allows traffic to go to the right arm branch, and in this setting it will allow the traffic to come straight in the straight section of the track. So this is how the switch and turnout works. So now let's just use a piece of wheel bogie with two axles that I had as a spare, and now let me run this on this section of the track and show it more clearly. So right now we have it set on the straight section of the track, and you can see if I run it, it will quickly pass through. So right now I have the bogie set in the straight section of the track, and you can see when I push it forward, because of the track alignment and the point setting, it will pass through to the opposite section of the track. So let's have a bit more of a closer look. So there's the wheel, it's making contact with the sliding arm, which is now set to the straight pattern, and this space here, because the other portion of the sliding arm has moved away, has created a space for the wheel to slide through to the other direction. So observe carefully and you can see how clearly the wheel can pass through to the other side. And once it reaches to the point where there is the welded joint, for this set of wheels there's no problem, because it can continue straight to the other side of the track. But for these two set of wheels which are going to pass through the welded portion, the joint portion, what will happen is, because there is an area in between which is empty space which doesn't have any rail support, there is a chance that the wheels could fly off at high speeds, and because of that there is this guardrail, the rail portion here, which kind of traps this other wheel and prevents it from flying off the rail. So this is the purpose of the section of rail here called as the guardrail, and also there is a smaller subsection of the guardrail on the other side as well. So when the wheel hits this welded point, it remains stable and continues to travel in the straight direction. If you want to make a high speed pass, it will be quite smooth. So as you can see, even at a higher speed, it can very well travel across the point to the either direction. Now, similarly on the other side, so if you want to move the traffic to the right arm branch, you got to push the lever and make the alignment such that the sliding arms are set to allow traffic to flow to the upper end of the arm, or coming from the upper end of the arm to the common section of the track. So I have the wheel coming in here. Notice how it will be aligned. So now you have a gap on the other side, and the arm here is aligned to the track, and the wheel will easily move on to that portion of the track. And similarly on the space near the welded joint, the guardrail on the other side and the sub guardrail on this side prevents the wheels from flying off when the train is traveling at speed. So in practice, I think there are joints and point sections which are created with certain speed limits and restrictions in mind, depending upon the nature and quality. There are some speed restrictions with which locomotive pilots need to adhere to when crossing sections, track sections which are switches and points. And because of this design is very much realistic in nature, it models the switch and points turnouts that you would see on real railroad tracks. And this is one of the good things about Fenfa sets. At such a fantastic price, you get such elements of realistic quality and detail, closer to actual detail, that it makes the hobby all the much more enjoyable and without hurting your pockets too much. So hope you are having fun and enjoying the series. Do let me know how you like these videos. I appreciate the feedback, and I'll certainly be able to churn out more with your support. So thanks a lot, friend. Enjoy.